circles omega and gamma have radii 2 and 3 respectively, and are externally tangent at point A. Let ABCDEF be a non-degenerate regular hexagon such that B lies on omega and E lies on gamma. The area of this hexagon can be written as A root B over C, where A, B, and C are positive integers, with A, C co-prime and B square free. Find A plus B plus C. First, the circles being tangent at A means that A lies on the line connecting the centers of those two circles. I will call those centers O and P, where OA is 2 because the radius of omega is 2, and AP is 3 because the radius of gamma is 3. We know nothing about ABCDEF other than that it's a regular hexagon, meaning all of its angles are equal to 120 and all of its sides have the same length, and B lies on omega and E lies on gamma. That's all we know about hexagon ABCDEF at the current moment. We can learn more about hexagon ABCDEF if we connect OB and PE, forming two new radii, which have length 2 and 3, respectively. Then we can work with triangles OBA and EPA after we do some angle chasing. And we start by letting this angle BAO here equal x. Then angle OBA is also equal to x, because triangle BOA is isosceles, with OA equals OB equals 2. It follows that angle BOA here is equal to 180 minus the sum of x and x, which is 180 minus 2x. Then angle BAE here is equal to 90 degrees. It's a right angle because if we consider the circle that can be circumscribed around ABCDEF, this circle has BE as a diameter, therefore angle BAE has to be equal to 90 degrees. And then back to the other circle, gamma. Because this is 90 degrees here, this is going to have to equal 90 minus x, because OP is a line, and it's equal to angle OAB plus BAE plus EAP, which should sum to 180. So EAP is 90 minus x, so is AEP, because isosceles triangles, AP is equal to PE is equal to 3, and then angle EPA here, this should be equal to 180 minus the sum of 90 minus x and 90 minus x. That's 180 minus 180 minus 2x, which is just 2x. So angle BOA is equal to 180 minus 2x, and angle EPA is equal to 2x. So it follows that the sum of the two angles is equal to 180. That's important because we are going to use the law of cosines on both triangles now. So the cosine of angle BOA is equal to negative of the cosine of angle EPA. This common value is to be denoted as n. Then we can use the law of cosines on triangles BOA and EPA. From triangle BOA, we have AB squared equals 2 squared plus 2 squared minus 2 times 2 times 2 times n. But from triangle EPA, we have AE squared equals 3 squared plus 3 squared minus 3 times 3 times 2 times minus n. By regular hexagon properties, triangle BAE has angles of 30, 60, and 90 degrees. So we have AE over AB is equal to root 3. So AE squared over AB squared is root 3 squared, which is just 3. So we can write this expression over this expression is equal to 3. We have 3 squared plus 3 squared is 18. 18 minus 3 times 3 times 2 is also 18 times minus n. Minus 18 times minus n is plus 18n. And that's equal to 3 times 2 squared plus 2 squared is 8. Minus 2 times 2 times 2 is also 8. 8 minus 8n. So dividing by 3 on the left side and right side, we get 6 plus 6n equals 8 minus 8n. Now subtracting 6n from both sides, we get 6 equals 8 minus 14n. And now subtracting 6 from both sides, we get 0 equals 2 minus 14n. 14n is equal to 2. We have n equals 2 over 14, or just 1/7. Now that we know n is equal to 1/7, we can sub that in for AB squared. And we get that it's equal to 8 minus 8n. And that's equal to 8 minus 8 over 7, which is just 56 minus 8, 48 over 7. To get the area of the hexagon, we need to multiply AB squared times 3 root 3 over 2. That's the formula for the area of a hexagon. It's side squared times 3 root 3 over 2. So we need 48 over 7 times 3 root 3 over 2. 48 times 3 over 2 is equal to 72. So we just have 72 root 3 over 7. A equals 72, B equals 3, and C equals 7. We want A plus B plus C, and that is 75 plus 7, which is 82. Our answer choice, C. And we are done. Thank you for watching this YouTube video, and please follow my channel if you would like to see more videos.